Since the dawn of human history, Mars has captured our imagination. In ancient skies, it appeared as a flickering red wanderer, a god of war, a celestial mystery. Today, it has become something else entirely, a destination, a bold frontier, the next great leap. And leading that charge is SpaceX, Elon Musk's ambitious aerospace company with a singular mission: to make life multiplanetary. A Mars colony, once science fiction, now occupies real planning meetings, engineering tests, and billion-dollar investments. But behind the dazzling renderings and the hopeful speeches, there exists a far more complex and daunting reality. The path to building a colony on Mars is not just about rockets. It is a gauntlet of engineering impossibilities, human limitations, environmental hazards, ethical dilemmas, and unknown unknowns. This is the truth about SpaceX's Mars Colony Challenge, a story not only of exploration, but of survival. When Elon Musk first laid out his plan to colonize Mars in 2016, it was more than a presentation, it was a manifesto. Humanity, he argued, faces existential risks on Earth, from supervolcanoes and nuclear war to artificial intelligence and climate collapse. Becoming a multiplanetary species is not a luxury, it's a necessity. At the heart of this vision is Starship, a fully reusable, heavy-lift launch vehicle designed to carry over 100 metric tons of cargo, or up to 100 people, to destinations across the solar system. With an ambitious pace of development, Starship is intended to dramatically reduce the cost of space travel, turning Mars from an unreachable dream into a logistical problem. But that problem is far more massive than it seems. Mars is, on average, about 225 million kilometers from Earth, nearly 600 times farther than the Moon. Depending on orbital positions, a trip to Mars takes between 6 and 9 months. That's not just a long flight. It's a perilous voyage across a void filled with radiation, psychological stress, and mechanical risk. Once you launch, there's no turning back. A colony on Mars is not a weekend getaway. It's a one-way ticket for most. The launch window to Mars opens once every 26 months. Miss it, and you're stuck, possibly for years. For SpaceX, this means not only transporting humans, but ensuring sustainable life support systems, massive redundancy, and psychological preparation. Every failure on Mars is magnified by distance. There is no help coming. Starship itself is one of the most complex aerospace projects in history. Designed as a fully reusable system, it must perform Earth launch, orbital refueling, trans-Martian injection, Mars atmospheric entry, and surface landing, all autonomously, and then somehow return. Mars' thin atmosphere, just 1% the density of Earth's, makes landing a spacecraft especially difficult. Parachutes don't work well. Retropropulsion is essential but dangerous near the surface. Even slight miscalculations in velocity, tilt, or fuel burn can result in catastrophic impact. Then comes the launch from Mars. Unlike the Moon, Mars has gravity, about 38% that of Earth, and an atmosphere. Any launch vehicle must be refueled on Mars, requiring the synthesis of propellant in situ using local resources. SpaceX plans to produce methane and oxygen from Martian CO2 and ice by the Sabaye process. But this technology has never been tested at Martian scale. A Mars colony is not just a rocket problem. It's a factory problem, a power grid problem, a habitat problem, a healthcare problem, a civilization problem. A human is not a rover. People require oxygen, water, food, heat, sleep, companionship, and medical care. They bleed, bruise, and break down. On Mars, The body is exposed to a series of threats that Earth's environment has long shielded us from. First, radiation. Mars lacks a protective magnetic field and thick atmosphere. Cosmic rays and solar particle events bathe the surface in high doses of ionizing radiation. A long-term colony would require buried habitats or advanced shielding, possibly using regolith-based bricks or water jackets to protect inhabitants. Second, microgravity. On the journey to Mars and during surface stay, humans will experience lower gravity. Extended exposure causes muscle atrophy, bone density loss, and cardiovascular deconditioning. We don't yet know the long-term effects of living in 0.38 G. No human has ever experienced it for more than seconds at a time. Then, isolation and mental health. Crews will live in confined quarters, thousands of kilometers from Earth, with limited communication due to the 7 to 22-minute delay. Depression, anxiety, interpersonal conflict, and cognitive fatigue could all jeopardize mission success. Psychological support, autonomy training, and even AI-mediated counseling may be necessary. Life support systems must recycle water and air, grow food or import it, handle waste, and protect against pathogens. A single failure in any of these could threaten every life in the colony. Elon Musk has proposed the long-term goal of terraforming Mars, turning it into a habitable planet with breathable air, flowing water, and Earth-like temperatures. While inspiring, the science behind this is currently more fiction than fact. To warm the planet significantly, we need to release vast quantities of greenhouse gases. But Mars doesn't have enough CO2 in its surface or ice caps to raise temperatures meaningfully. Even optimistic models suggest centuries or millennia of effort, requiring planetary-scale engineering, nuclear devices, orbital mirrors, or massive atmospheric factories. And even if we succeeded, the atmosphere could be stripped away by solar wind, just as it was billions of years ago. Mars will never be Earth. It can be a base, maybe a series of domed cities, but not a blue, fertile second home. Not without technologies we haven't yet imagined, and not anytime soon. The very word colony carries historical weight. Is Mars a blank slate, or are we repeating old patterns of expansion and exploitation? We must ask, who decides who gets to go? Will Mars be a refuge for the rich, a playground for tech billionaires, or a shared project for all humankind? Who owns Martian land? What laws apply? What if someone refuses to follow them? The Outer Space Treaty of 1967 prohibits any nation from claiming territory in space, but does not regulate private companies or settlements. Legal gray zones abound. Future Martians may need to craft their own systems of governance, law, and justice. There's also the question of Martian life. If microbial life exists below the surface, are we contaminating it irreversibly? What are our obligations to alien ecosystems, to future generations, to the planet itself? The colonization of Mars is not just a technological challenge. It's a moral one. SpaceX's vision is grand, but it's not cheap. Starship's development costs are estimated in the tens of billions. A full-scale Mars colony would require trillions over decades, far more than any single company can afford alone. Where does this money come from? Government partnerships? Private investors? Will Mars missions be pay-to-play? Sustaining interest, political, financial, cultural, over decades will be hard. Grand visions often falter under the weight of practical compromise. Without consistent public support, Mars colonization could stall, leaving behind rusting prototypes and lost dreams. And yet, despite all this, the ambition remains. Why go to Mars? Why risk so much? Because Mars represents more than a rock in space. It is a mirror reflecting our fears, our hopes, our potential. Reaching Mars requires the absolute best of our science, our ingenuity, and our courage. It forces us to ask what kind of species we want to be. Do we stay bound to one fragile world, or do we take our place among the stars? Even if we fail, the attempt may spark a renaissance of science, technology, and collaboration. It may inspire generations. It may teach us how to live better here on Earth, how to survive, adapt, and protect our own biosphere. Mars is not a backup planet. It is a test of our maturity as a civilization.